Okay, let's look at the math. The math of series circuits, we want to find resistance, current, voltage in our series circuit. And what I'm referring to, the total resistance for my series circuit, the total current for my series circuit, and the individual voltages across each resistor. While we do the math of circuits, because we use Ohm's law repeatedly, it's very simple to get confused. It happens quite a bit. The key things to remember about a series circuit, what makes it different in terms of the math, is that the current is the same throughout the circuit. And the voltage is different. And it's different across each resistor. Voltage is different across each resistor. Those are the two key concepts. When we do parallel circuits, we switch that. It's the current that changes and it's the voltage that stays the same across a parallel resistor. And it drives how you solve the math problems. So things to keep in mind. What I want to do now is to go back to the pictures when we're done writing here. To find the total resistance in a series circuit, it's really quite easy. We simply add everything up. We add up all the resistors that are in a row, however many there are. And that's our generalized formula for finding total resistance. And generally, that is our first step every time we solve the math for a series circuit. Total resistance equals R1 plus R2 plus R3 plus up to R whatever, R100. However many resistors you have in series, you add them up. Okay, so we always begin there. Then we can find the current. Then we can find the voltage drops. So those are our steps. Resistance, current, volts. Anybody still writing? Let's go to this top one. I'm going to make some numbers up to go in here. They don't have to be the same resistor either. Like, let's take this first resistor and make it 10 ohms. And let's take the second resistor and make it 20 ohms. And let's assume it's a 9-volt battery. What I want you to do is figure out the total resistance. We're off the page slightly. Let's move it over. Total resistance, total current, and I want you to, we'll call these resistors 1 and 2. The voltage across 1 and the voltage across 2. That's what I'm going to want you to find. So, right away, we should be able to find the total resistance. Olivia, how would I do it?
You add 20 ohms.
10 ohms.
Or 10 ohms.
Sorry.
Yes,
Precisely. Nice job. All right, so I'm off the page, sad to say. Let's slide it on over. All right, 30 ohms. 30 ohms is my total resistance. With that in mind, I can solve for current because my total voltage is 9 volts. As long as I'm using the totals for everything, I can use Ohm's law, V equals IR, and I can solve for the current of the entire circuit. So, Joe, tell me how I would do it. Joe Ullman. Divide volts by resistance, good. And I would have it. So I'm looking at 9 volts divided by 30 ohms. And this will tell me the total current of the system. So 9 divided by 30, 0.3. Oh, I should have been able to do that in my head. 0.3 amps. So it doesn't matter that it's a 10 ohm resistor and a 20 ohm resistor. They're each going to have 0.3 amps, a third of an amp going across them. What is going to change is the amount of energy it takes to push that current over those resistors, the volts. The amount of energy used to push that is the number of volts, and that's going to be different depending upon what kind of a resistor you have. Now, Courtney, what do you think? Which one's going to need more energy, the 10 ohm or the 20 ohm? The 20 ohm. Why would you say that? Okay, and what does resistance mean? Keep going, you're almost there.
Push electrons.
Yeah, exactly. It takes more energy to push the electrons through that resistor. Okay, so I would predict that it's going to take more energy here, so my number of volts when I solve it will be greater than the 10 volts. However, if I add the two values up for the volts, Hannah, what do you think? What should they add up to? What's my total amount of volts? 3? It's 9. I have a 9-volt battery, so I certainly can't have something add up to 12 or 15. Right? Whatever the amount of volts is for here and here, those numbers should add up to 9. So I can check it in my head. All right, so let's figure it out. For V1, if I know that each of these has 0.3 amps, and it's exactly the same, I'm going to use Ohm's law again to figure out the volts. V1 will equal my 0.3 amps, and I'm going to multiply by 10 ohms. Alright, so it gives me 3 volts. Now, with this in mind, I could just subtract. 9 minus 3 gives me 6. Let's just make sure that it works with Ohm's law. 0.3 amps times 20 ohms. Oh boy, lucky for me, it worked out. Alright, 3 volts and 6 volts for each of my resistors. Not so bad. Not so bad, right? Change colors here. Let's do the next one. 5 ohms, 10 ohms, 15 ohms, and 20 ohms. Let's make it a car battery. Let's make it a 12-volt battery. First thing I would like you to do, put a line there so we can see what we're doing. Find my total resistance. Sean, what would it be? 50. How'd you get it? 50 ohms.
Add up all the
Exactly. I just add them all up, get 50 ohms. Okay, what's going to be my next step? What can I find now? Chris, what should I find now? I would find the amps as well, yes. So V equals IR. If I rearrange it, I do volts divided by resistance. What number should I put in there, Chris?
12 volts divided by 50 ohms, which gives me 2.4.
Wonderful. And then you have to type it on my calculator. Thank you. Okay, that seems pretty reasonable to me. All right. Now, my 0.24 amps. Which one of my resistors is at 0.24 amps? All of them. Right. It's not just for a single one. Each one is at 0.24 amps. The current is exactly the same for all of them. However, my volts aren't. Where do you figure it's going to require the most energy, the most volts, to push the current through? Yes? The one that has a resistance of 20. And why would you say that? Exactly. More resistance requires more force in the end, more volts, right? More energy to push it across. It's harder to do it. So it's going to require more energy to do so. So I would predict my number on the 20 should be the largest. How am I going to find, let's just pick the 15 volt resistor. Let's just find this one to save ourselves a little bit of time. Jack, help me here. Let's find the voltage drop across the 15 ohm resistor. Okay, 15 what? Ohms. Okay, there's my resistance. Times what? 4 amps. Okay, that should tell me the voltage drop just across that particular resistor, which is 3.6 volts. Now, Zach, if I kept doing all of the resistors the same way, and figuring out the number of volts. And I had 4 voltages at the end. What should it add up to? 12. Because I'm never going to have more energy. Right now, keep in mind, we're ignoring the wires, everything like that. That's fine. We can do that. In fact, we do that regardless. We can't figure out necessarily the resistance in the wire, but there is some. So our calculations aren't perfect. You'll probably notice that when you do your electric houses. Alrighty then. Parallel circuit time. Series circuits are pretty straightforward. Parallel circuits can be a little bit trickier. And then tomorrow, the plan is to do combination circuits. I believe your next web assign isn't due tomorrow. It's due, I want to say Friday. Does that sound right? Nicole, would you mind stopping the tape and just restarting it now? Because I'm going to chunk this into